Hello, everybody. Welcome to our third session in the gallery today, and welcome to .local London. We have the pleasure of having one of our senior product managers here with us today. Seth Payne is here from the States, and as the title of his talk already suggests, Seth is a man who likes the opposite ends of a spectrum. Tidbit about Seth? He is probably right now the biggest Slayer fan present in the city of London, having been to 54 of their gigs. He's also a trained classical violinist. So no wonder he's going to talk us through how to integrate the diverse user needs of MongoDB and SQL. Seth, stage is yours.
Thank you very much. Have we switched over to my laptop? Yes? Oh, good. OK. Great. Well, thanks, everybody, for coming. It's a great turnout. So yeah, my name is Seth Payne. I'm a product manager. I work out of my home in Seattle, but most of the engineering teams that I work with are based in New York, so I split my time between New York and Seattle. Today, I want to talk to you about MongoDB and SQL, and that may sound like an interesting or a strange combination, but I want to specifically focus on how you can be better equipped to meet the needs of your users by providing them access to MongoDB data in a way that perhaps you haven't considered before. So here are some goals that I laid out for today's presentation. I want to enable you to be able to query MongoDB using SQL. I'm going to provide you an end-to-end overview of how that's possible through the BI connector, which is the product that I'll be describing today. And I'm going to teach you how to manage schema mappings between an underlying document structure and an abstracted out SQL schema. So we'll go into detail there. And then finally, I'll demo quickly how to connect to and query MongoDB from a MySQL shell. But you guys have a homework assignment as well. So when this presentation is over, I would like you to go and download BI Connector 2.12. We just released that last week. Query MongoDB using our default schema mapping. Then get creative and create your own custom schema mapping. And then query your MongoDB data using that custom schema. But before we dive into that, I want to tell you a little bit about myself. So this is a picture of me about 20 years ago. This was in Chicago, 2000. I think it was April. And boy, I was a lot better looking then. Boy, if I could go back and tell that young man some things. But the point here is that I started my tech career as a partisan in the great Linux versus Windows war back in '99 to, I'd say, I don't know, it wasn't until Windows Server 2003 that I really thought that Microsoft kind of caught up. So I was involved in that very heated exchange, and so I kind of was introduced in tech to this whole idea of people having very, very strong opinions about technology and really enjoying arguing about it. Now, at that point, it was Slashdot, now it's Hacker News, but it's all kind of the same. So when I came to MongoDB, this was an advertisement that we put up outside of San Francisco just a couple months after I joined. So I think this illustrates that the relationship between, or I should say the attitude that MongoDB has had towards relational databases has not always been a friendly one. And so I have somewhat of a unique role here at MongoDB. I act as a peacekeeper between MQL and SQL. And so I'm going to talk you through how you can provide SQL-based access to your end users to MongoDB data, and how all of that works. So, the data landscape is changing. I mean, 10 years ago, you would have been thinking, okay, what database do I want to choose to support, this broad set of applications? And the conversation is really different today. The conversation is about, okay, what technologies do I pick and combine together to meet these complex data workflows that I need to serve the needs of my users? So the questions are changing. You guys are in a position where you're having to integrate and work with a disparate range of technologies. And so at MongoDB, as we want to build ourselves out as a data platform and not just a database, we have to be able to interface with a wide range of technologies. So that, of course, is how SQL comes into the conversation. So data technology is like life. If we want to accomplish anything big, we have to be able to talk to each other. But at the same time, it's okay to have really strong opinions. Like, for example, I have a strong opinion that MQL is the best way to interrogate and query data. But I also acknowledge that SQL is widely adopted, and it is the standard for many, many, many tools out there. And so at the end of the day, we need to focus on results for our users. That's what really matters. Our users don't really care what our opinions are, just as long as they can get their data, they can get their reports, et cetera. So that's really what matters. And I think everybody in this room would agree with that. That's where we are. So this is the vision that we have for our customers at MongoDB. So as I go out and talk to some of our customers who've been with us for many years, they're trying to create an operational data layer centered on MongoDB. But as you can see in this diagram, we're dealing with a lot of producers of data, a lot of different consumers of data. And at MongoDB, we are, as I mentioned, creating a platform where all of these different things can be integrated into this single operational data layer. So what I'm going to be talking about specifically today is on this MongoDB connector side, specifically BI, as it relates to SQL. Although I want to stress that the SQL-based access to MongoDB is not restricted to just BI use cases. So I'll talk a little bit about that later on. In the past, we've kind of focused on Tableau and MicroStrategy and Power BI and kind of the end user experience. I don't really want to do that today. I want to focus more on the admin experience for how you provide your users access to data. That's really what I want to focus on. So what's the core problem that we're dealing with? So here I have Jane. She's a DBA for MongoDB, and she just learned that there's an analytics team that requires SQL-based access to data that's in MongoDB. As I'm sure many of you are aware, ETL is a complex and error-prone process, and so she wants to avoid that if at all possible. So the core problems that Jane needs to solve are that MongoDB admins need a way to provide business users access to MongoDB, and SQL-based applications need to be able to read data that sits in MongoDB. So how do we solve that problem? Well, that's where the BI connector comes in, and I hate the name BI connector. It really should be called SQL proxy or SQL connector because that describes what it does and what it is. So essentially, the BI connector is it's a process that can run it can run anywhere. It can run locally. In fact, the demo I'll do today is going to run local on my laptop. But this is just a service, a binary that can run on a secondary node. It can run on its own node. It can run anywhere as long as it has access to an underlying MongoDB replica set. Or standalone. It could work with standalone just fine too. So what does it do? The BI connector provides read-only SQL-based access by translating incoming SQL queries to MQL aggregation pipelines. It then retrieves those results, puts them back into a tabular format, and returns it to the client as if they were querying a MySQL database. So in terms of connectivity, we provide connectivity to the BI connector via ODBC, JDBC, and the MySQL wire protocol. So any application that you have that can speak via these protocols can access the BI connector and can query MongoDB using SQL. So let me tell you a little bit about the history of the BI connector. It was released about 3 years ago, maybe a little, I'm not sure, 2016, somewhere in there. And version 1 was really a proof of concept. We had customers who had data sitting in MongoDB, and they had, these customers had business users using Tableau who really needed to access the data. So our early versions of the BI connector were hyper-focused on Tableau. We were really just worried about understanding the query shapes that were produced by Tableau and by different BI tools. And if you guys have never looked under the hood at some of the stuff it's amazing how they shape some of those queries. So that was not exactly an easy problem to solve. So that's where we were focused early on. And that, it met the needs. We actually proved out that, hey, this is something valuable. This is something that customers can actually do, and we could pull it off with some degree of success. And so as we went into versions 2.0 to 2.4, we really focused on expanding our SQL function support and always trying to get performance where it needed to be. And then in versions 2.5 to 2.10, that would be mid last year to I'd say March of this year. We focused on improving usability. We have near 100% coverage of SQL functions. And this was the first time actually in the last year that we were actually able to displace a DB2 instance at one of our customer sites because they were just able to put the BI connector in front of MongoDB, and they no longer had to do an ETL process between their MongoDB database and this DB2 instance, so it saved them a bunch of time overnight. They were running these huge batch jobs. So that was great to be able to see that we'd gotten the BI connector to a point where business users at this customer were satisfied enough to be able to rip out the existing solution. So that was great. Now, in 2.11, which was released in May, and then of course 2.12, which was released last week, we've really focused more on enterprise management features. We released a utility called Mongo Translate, and I'll talk a little bit more about that later on. And of course, we continue with query optimization and performance improvements. So the question is, well, how well do we do? And so I took a look at the numbers for all of the SQL queries that were issued in Atlas, our MongoDB Atlas service, in August. And we processed 414 million SQL queries. And of those queries that came in, we were able to translate, and I mean completely translate, 99.71% of the SQL to an exact what would produce the exact results in MQL. So we're pretty confident at this point that we know what we're doing in terms of translating between SQL and MQL. And so it's not surprising that we have happy customers, and we've seen our adoption really skyrocket. So it's very exciting for us. So how do we make all of this happen? Well, of course, if you're going to query via SQL, you need to have a relational schema that maps to an underlying document structure. And there are a few ways that we make that possible. As I mentioned before, the BI connector is presented as a MySQL database. So when your clients connect via the MySQL shell, ODBC, JDBC, whatever, they think they're connecting to MySQL. They have no idea that underneath the hood they're actually querying Mongo. So it really is just connecting to a MySQL database. We do create an abstracted relational schema, which again maps the SQL schema to an underlying document structure. And we have a few different ways that we can define that schema. The first is through sampling, and I'll talk in more detail in a few minutes about each of these. But sampling is basically where we go in and we take look at 1,000, 5,000 documents, and we look at the fields and the data types and all that, and then we have certain logic that we apply that creates a relational schema. A lot of customers love that. It's fine. It meets their needs. It's great. But I'll talk about a couple of use cases where you may want to be a little more creative than that. And then we also have the document relational definition language, so MongoDB. And this allows you the ability to customize a schema. And I'll give you some specific examples of why you may want to do that and when you may want to do that and how you do it in just a moment. But first, let's talk about our defaults. By default, if you just download the BI connector, it's a binary MongoSQL-D, and you start that up with no options. You got MongoDB running on your local host. What will happen is MongoSQL-D will connect to MongoDB. It will sample, by default, 1,000 documents from a namespace that you either tell us explicitly to sample, or we'll just do the whole, all of your databases. And then we create that relational schema between the document structure that we've sampled and what is going to be presented to your users who are connecting via SQL applications. So at a high level, databases are mapped to databases in terms of naming. Collections are mapped to a root table. Fields become columns, and arrays and objects are represented in subtables. And we'll get a little bit more into detail on that in a moment. So take a look at this document structure. Again, I'm a big fan of Slayer, so I have a couple of examples here. You can see that this document has some top-level data. It has a popular albums array, and it also has an array of objects. And so if we were to sample a collection that had this document structure, this is the SQL schema that would result. You would end up with a bands root table, bands underscore members as a subtable, and then popular albums also as a subtable there. And then, of course, if you wanted to join all of those together, you do so on underscore ID. That's how we create the relationship between the subtables and the root tables. And we've optimized joins. We called this self-joins. So these are actually very, very performant. And so this is, for example, how you would join all of this data together based on the default sampling that we would do and the default schema that we would provide through the BI connector. But as I mentioned, sometimes that may not be ideal. A lot of documents have a lot of data, a lot of fields, and perhaps your end users don't need to see the 1,000 fields that are in a document, or they may not be interested in some of the data that's embedded in an array or in an array of objects. So you may want to get creative. You may want to change that up a little bit. So the way you do that is through a utility, as I mentioned before, called MongoDB. It ships with the BI connector. It's just another binary that's there. You run this binary against your database, and it provides a schema that you can then edit and you can work with. And of course, this first schema that we'll provide you is based on our default sampling logic, and it defines both names and data types. And then once you have that initial output, you can edit and change things to your liking. So let's take a closer look at what this process looks like. How would you go from the default sampling logic to a custom schema that meets the specific needs of your users? So the first thing you would do is generate MongoDB output. Command line utility, you get that, put it to a file. You edit the output to reflect the desired schema. This means you may be changing data types. Perhaps you're going to apply an aggregation pipeline to create a specific document structure. Once you're happy with that layout, you would import the schema to MongoDB. And when I say import the schema to MongoDB, that means that we take that Dreidel definition and we store it in a collection in a document. And so you can import as many different custom schema as you would like, and you can give each one a unique name. And then when you start the BI connector, you simply point to or you don't point, you just name the schema that you would like to load. And so you have that flexibility to really load up whatever schemas you have. So for example, we have some customers that are serving an accounting department and maybe serving a finance department, different data needs there. They will set up a BI connector for accounting, and they'll use an accounting schema. And then they'll have a BI connector that is for finance, and it'll have a finance schema. Both of them still map to the same underlying MongoDB data, but they represent completely different relational schema as they're presented to the end user. So let's dive into this in a little more detail. So I mentioned the first thing you want to do is create your MongoDB output, and this is the command you would use. You need to specify your database, your collection, and as I mentioned here, redirect the output to a file. That's usually what is most commonly done. So looking at, going back to that original example, that original document that I showed you before, this is the result of the MongoDB output. So you redirect this to a file. This is what you get. It's a YAML file. So yeah, you have to worry about white space. Sorry about that. And you can see that in this file, we've got a database that's named. We have tables that are defined, and for each table, we have a mapping between the Mongo field and a particular column name. And you can also see that we identify the data type as well. And in a lot of cases, if we see different types of data, in the same field. So for example, some of you have a field called foo, and some of them have strings, and some of them have ints and whatnot. We'll just default to varchar in that, and usually that makes it simple enough, and then we can do different typecasting and whatnot later on if we need to. This is additional output that you would have. So now, this is a long bit of output here just to describe this very simple document structure that I showed you before. So this shows what is done by default, as I talked about before, and this represents where we want to be, right? So our users, we know we want to give them data that exists in this underlying collection, but they don't need all of that data, right? They might be creating specific dashboards, they might be doing something very specific, they might not be that sophisticated, so you want to keep things really simple in terms of schema and querying. And so what we really want is just one table that projects out or provides access to just a certain defined set of fields. So how do we do that? Well, what we do is we first define the document structure that we want by generating an aggregation pipeline that reflects the document structure that we want to then build our relational schema on. We add that to the Dreidel file here in the beginning, so you can see we've still got the tables defined. We add this pipeline here. Now what this does is this will mean that every time that a query is issued via SQL against MongoDB, this pipeline will be run to generate the document structure that you want, and then we will map the SQL schema based on the document structure that results from the aggregation pipeline. So this is what the end result looks like. So it's a lot smaller. We're just going to project out a few fields. We've done an unwind on a table, and we're going to project out just a small subset of what we want our users to see. So once we're happy with that schema, once we know that that's what we want, we need to get that into MongoDB. We need to upload that, import it into MongoDB. This is the command you would use to do that. So I have, in this example, named bands_flat as my edited schema, my Dreidel file there. And then I identify a schema source, and this is the namespace in MongoDB where that schema will be stored. And as I mentioned before, you can generate as many different schema as you would like, and then when you launch the BI connector, you can pick whichever schema fits the use case that you're launching that for. Okay. So yeah, and then this is the command that you would issue to actually start the BI connector, and you can see that I'm pointing to a specific schema. I'm identifying my schema source, and I also have a schema mode of custom. And so that differentiates it from, say, our standalone mode, which defaults to sampling. So you would call it this way. So what's the result when that happens? Well, if I do a describe bands, you can see that because of the aggregation pipeline that I put at the beginning of that Dreidel file, I'm dealing with a much smaller set of data now. And so I've mapped just 4 different fields here, actually 3 fields, and an underscore ID is just done automatically. So you can see that I went from a fairly, I wouldn't say it's complex, but you had a root table and some subtables. And so if you wanted to get information, you have to do some joins. And like I said, maybe your users don't want to do joins. That's maybe not necessary if they only need to see a small set. So you have the ability here to simplify the SQL schema that's presented to your end users. Okay? All right. I'm going to jump into a demo real quick here. Okay. Can everybody see that okay? Do I need to zoom in? Okay. So this is MongoDB Compass. Elliot used this morning. We saw a little bit of this in the keynote this morning. This is a great way to take a quick look at your data. The most useful thing I find about it is the aggregation pipeline builder. I use it all the time. So I want to show you what data I have here. Now, I'm a football fan. I actually like college football in the U.S. more than I like the NFL, but I like the Seahawks, you know. So I can't complain. So this is a data set which represents the last 18 NFL seasons. Now, I've created a document structure here which represents every single kickoff that has happened over the last 18 years. And so I've got information about the kicker. I know where they went to college. I know how much they weigh. I know how quickly they run the 40, you know, their wingspan, all that kind of stuff. I've got all that information. I have that for both the kicker, the returner. I have game details. I can tell you what season it was, what week it was, what the conditions were, what surface they were playing on. Like, I got a lot of data in this collection here and in this document. But I'm dealing with some end users who really don't care about most of this data, right? So I don't know, imagine, for example, that I've got some sports analysts that are really just interested in a small subset of, say, what's the net, the kickoff net, right? Which is the difference between, of course, the total yards of the kickoff and then the return. So in order to provide that view and provide that SQL schema to my users, what I've done here is just use $bucket. So I just have a fairly simple ag pipeline here. It's just got a single stage. But what I'm doing is I'm grouping by the kickoff net, and I'm putting it in different buckets, which represent all the way from -50 all the way up to 100. And so I've then pulled in specific data about what's the average overall for these buckets, and then what's a little bit of information about the kicker, what's a little information about the returner. And one thing that's interesting that I don't know if anybody's an NFL fan here, kickers can play a long time, right? I think Mortensen was like 46 or something when he retired, and so it's interesting because I was just curious. I pulled the data, and if you look at like the average what's the word I'm looking for? Age of the players. There's like a good 2 to 3 year difference between the kicker and the returner in most cases, which I think is pretty interesting. So anyway, this is the document structure that I wanted. So remember, I started with this massive document here that has a lot of data. But I know my users don't need all that data, right? Maybe they're doing Tableau. Maybe you've got some analytics developers which are just creating some data. I don't know. They don't need all that information. And so to simplify their workflows, to simplify their interaction with the MongoDB data, we're gonna provide them with this document structure. So what I've done here with this $bucket stage in this pipeline is I'm grouping again on the net return. I'm giving a total count for what exists in that bucket. I'm giving an average career start for the kicker and the returner, and then I have an array for kickers and returners, and in each one of those I have their name, their rookie year, their height, weight, college, and the conference, their college conference. So in any case, this is the structure that I'm going to then base the SQL schema on. So I'm going to go ahead and start up BI Connector. I've already imported the schema. So let's go ahead and start this up. So BI Connector comes up. It's gone ahead and created that schema based on the definition that I've created there. And if I want to log in to my MongoDB data using the MySQL shell, I just go ahead and do that. And I've written some shell scripts here to make it simple for myself. So if I do show databases, you can see that we see what we'd expect. You standard MySQL table or database, the information schema database, and then of course the NFL database, which is the specific database that I'm calling out in my custom schema. So let's say use NFL, and let's do a show tables. So what I've done here is I have a root table for the broad bucket definitions, and then I have a subtable for each for kickers and returners. So let's do a describe on one of these here. The kickoff. So you can see that this is the relational schema that's provided here. And again, this was all controlled and all mapped using the aggregation pipeline and then that dreidel definition where I'm renaming things, I'm moving things around, and maybe I'm changing. I didn't have to change data types in this case, but if I wanted to, I could have. So that's the data that I'm dealing with. So take a look here. Again, I don't know if you guys are like this, but I'm doing demos and like typing in a terminal, I always screw things up. So like I like to have these scripts here. So these are some queries that I'm going to run. So if I do a cat here on, say, return player, you can see that this is a SQL query that I've put in this script here. So let me go back to my, let me just copy this here. And I'm going to go back to the MySQL shell. And let's do source return player.sql. And there it is, right? So what do I have here? Well, my SQL query has grouped by player, given me the total count of kickoff returns that they've had in that 18-year period. And it also gives me the average bucket that they're in. So what's interesting here is this is a pretty strong indication that most kickoffs are about 20 yards, you get a return on that, which in college, that would mean you wouldn't want to return it because you start on the 25. In the NFL, you start on the 20, so it's probably a good idea to run it back. But in any case, that's what comes out pretty strongly here. If I wanted to do another type of query, let's just take a look at return college. So you can see that's a little different there. I'm actually going to look at their college and do a count based on which college they went to. So let's do that. Sorry, let me copy this just so I get it right. Okay, so I'm old enough to be an uncle now. And so now that I know how to wrangle this data, if I had a nephew or actually a niece plays college football in a couple of cases. There's some great female kickers out there. If they came to me and said, Uncle Seth, where should I go to college? I really want to be an NFL kicker. Where should I go? I would say, hey, go to Kansas State because they have a lot of kickoff returns and they're doing pretty well there with the count, right? So this is just interesting data to play with. Again, this is a fairly simple example of how I'm taking this very large document, which has a lot of information, and I'm just cutting it down to meet the very specific needs of my end user, who in this case just wants to take a look at some basic information about kickers, returners, average returns, what college they went to, all that kind of stuff, right? Okay. Now, let me tell you a little bit about Mongo Translate. So Mongo Translate is a utility that we released as part of our 2.11 release, and it takes two pieces of input. It takes a schema definition in the form of a Dreidel file, and it also takes a SQL query. Now this can be submitted as a string on the command line, but usually I tell people put it in a file because a lot of times you're going to have backticks and whatnot in your query, and Bash and other shells don't necessarily handle backticks very well. So it's usually easier to read things from a file. So again, I like shell scripts, simple ones. So let me just cat this translate demo to show you exactly the syntax that I'm using here. So again, I'm going to use Mongo Translate to run a similar query or to run the same query that I just showed you in the MySQL shell, and let's see what happens when I run that. Oops. Okay, so when I provide a SQL schema and I provide a query file, you can see that the output I get is the aggregation pipeline that the BI connector would use to execute that query directly against MongoDB. Now, I kind of snuck this in because last year I did a lot of interviews with customers really trying to understand what their needs around SQL were. I was really interested in how folks who were really well versed in SQL made the transition to MQL. And what I kept hearing from customers was, just give us a little help, right? Just show, like, if you just get me started with aggregation, that can really help me out. So we provided this Mongo Translate tool, and so you can see that it's fairly easy to issue these SQL queries against or using Mongo Translate, and you can see what the resulting aggregation pipeline would be. So the way you get your hands on Mongo Translate is you download the BI connector. It's just a binary in there, so you can have 3 binaries. You can have Mongo SQLD, you can have Mongo Dreidel, you can have Mongo Translate. Okay, so one thing I will mention is that you should probably keep your eyes out because Mongo Translate will probably find its way into Compass at some point. That's something we're talking about. So we'll see how that turns out. I mean, it will end up there eventually. I'm not sure the timing on it. But again, what we want to do is kind of ease that transition to MQL, right? I mean, our vision is not for people to query MongoDB using SQL as the default, right? Like this is just because you've got users that need that, and we want to serve their needs. But I mean, if you're doing application development, clearly we want you to write with native drivers. We want you to go directly against MongoDB. There's no reason to go through this translation layer, and so we're hoping that a tool like Mongo Translate can help your users who are newer to MongoDB kind of get acquainted with aggregation and kind of build on that. And I should mention that everything I've gone over today, I just did 2 blog posts on this, so all of the details about the bands and everything that I did, and I think I don't know if I cover Mongo Translate in that blog post, but you'll get the basic idea. So everything I've referenced today, you can go find those blog posts, and you can see all the detail there, see all the commands that I've issued, all that kind of stuff, so you can go try this yourself. OK. Let me go back to the presentation. OK, so I'll just reiterate what I said about Mongo Translate. So again, we're taking SQL input, and we're going to translate that into MQL aggregation language. The inputs, like I mentioned, needs to be a Dreidel file, which represents your SQL schema. Now, to be honest, when we look at doing this in Compass and in other places, because what's neat is we've got this translate engine, and we can start to use it in different places. So Compass is like one of the first places we'll look at using it. But we're looking at some interesting things where we can infer a schema so that you wouldn't necessarily need to provide an explicit schema, things like that. I mean, so that's a better UX overall. So those are things that we're thinking about. Those are things that's the direction we want to head. But for now, you do need to provide an explicit schema mapping, which represents your relational schema. You also need to have a query string or a file. Please use a file. It's going to save you a bunch of time. And then the output, of course, is an aggregation pipeline. And you should be able to take that aggregation pipeline and paste it directly into the MongoDB shell and get the results that you're expecting. OK. So again, if I'm starting with this as my SQL query, I would issue Mongo Translate against that with the query file. In this case, I'm explicitly naming the database as well. And then the result is this aggregation pipeline. So again, it's an interesting learning tool. It can maybe be of some help to your users who are new to MongoDB and aggregation. So let's revisit some of the goals today. I've kind of blazed through this presentation here a little quicker than I expected. But what did we want to accomplish? I wanted to enable you to query MongoDB using SQL. I think I've given you the basics on that. And again, I have two blog posts up written with my colleague Meir. And so again, you can reference that and run through these examples here. So that's something you can do on your own. I gave you an overview of how the BI connector works, how we handle that translation, how we represent it as a MySQL database. I've taught you how to manage the schema mappings, whether you're going to use default sampling or whether you're going to go ahead and create a custom schema on your own. Really, again, this is all about meeting the specific needs of your end users, right? And again, I want to stress, like I've showed you some fairly simple examples today. We've got customers doing some pretty incredible stuff with the schemas that they present. And I've also given you a demo about how to query via the MySQL shell. So now I want you to go out and download the BI connector, query using the default schema, create your own custom schema, and then query using that. So again, you can just grab the BI connector from the MongoDB Download Center and get started querying MongoDB with SQL today. So thank you very much. I think we have some time for questions if there are any questions. OK, we'll get.
Hey, thanks for your presentation. The quick question is, can you have multiple root tables? Because if you have a big database, multiple collections, you will end up.
Can you speak up a little bit?
Can we have multiple root tables when you try to convert from collection to the tables from the relational perspective? Because you can have multiple collection in your Mongo database, which may end up multiple root tables.
Yeah, that's a really good question. So today, for each defined schema, there can only be one root table. You could define multiple schema that are mapped to the same underlying collection, and they could have different root tables. But for each defined schema, there's one root table, which represents the top-level data in your collection.
OK, but in that case, then how would you join those two schemas? Is there a way to kind of cross-reference the tables?
Well, yeah, so are you talking about the joins between, say, the embedded data and your, yeah, so you would join on the underscore ID. So when we unwind the embedded arrays or the embedded arrays of objects, we will insert the top-level documents underscore ID so that you can perform the join across the root table and the subtables.
All right,
yeah.
Thanks.
I think we had a question up here. In terms of reading data that way?
Answer the question?
So the question was, can this be used with Microsoft SQL Server? Maybe. We don't officially, well, we don't support the linked server concept at this point. It's something that I've been thinking about and talked to Microsoft a little bit about. So it's something we could possibly do. Now, if you're just connecting as a read-only and you're pulling data in, absolutely, you can do that from SQL Server, no problem at all. As long as you can just make that either, again, ODBC, MySQL, JDBC, you can pull that data in. Right now, though, BI Connector is read-only, and so you are just going to be pulling data in one direction. Yeah. Question over here?
Hi, thank you very much. You mentioned your blog posts. Where do we find those?
So is it mongodb.com/blog? Is that what it is? Yeah, so if you go there and just search my name, it'll pop up. And they were like last month, I think, so they should be pretty easy to find. Yeah. Any other questions?
So the Power BI connector, is that an ODBC?
Can you speak up a little bit?
Sorry, the Power BI connector, is that an ODBC and or JDBC driver?
So with Power BI, yeah, with Power BI you would use ODBC. In fact, I kind of forgot to show this, but here I'm on a Mac, but this is Tableau. I've connected via ODBC. Yeah, so with Power BI it's the same thing. Now I will give you a heads up on something with Power BI. Power BI does like a full data load when it's not working with a SQL Server database backend. So the way we're tackling that issue for our customers is we're going to integrate with the data gateway that a lot of folks use with Power BI. Once we're integrated with that data gateway, those load times will become a lot better. And this is a known issue with Power BI. And so, yeah, we hear that feedback from Power BI users once in a while. If you have a large data set that you're loading in, it can sometimes take a little while, just because of the way Power BI functions. Show of hands, I'm actually curious. How many of your users are Tableau users? And then Power BI? Really? Okay, interesting. Interesting. Yeah, I'm actually seeing a shift lately, talking to customers over the last couple of years. More and more folks are adopting Power BI over Tableau. I think that's of course, I mean, $1,000 versus free probably explains a lot of that. So anyway, just curious. Okay. Any other questions? Okay. Well, hey, feel free to grab me after the session here. And of course, my email address is seth.payne@mongodb.com, so hit me up there if you'd like. And thanks again for coming today. Really appreciate it.